All right, so my name's Leah Murphy. If you don't already know me, I'm obviously a senior MUI, and my capstone is called, I'm calling it the Cycada, which is basically a Bluetooth MultiFX Stompbox. And so why Cycada? One, they're my favorite bug, and I have fond memories of it as a kid. Growing up in Chicago, we had the cicadas that would come around every 17 years and make these amazing noises. And I was like, well, that's so cool. And then also when making this pedal, I encountered so many audio squeals and glitches and pops and clicks and noises that really sort of reminded me of a cicada. And that was just the natural process of creating this pedal, and working through the audio bugs, I guess you could say. So that's sort of what inspired the name. So I guess to start off, we need to figure out what is a MultiFX Stompbox. And there's a couple really popular models that are already on the market. There's Neural DSP Quad Cortex that just came out. Line 6 is HX Stomp or Helix Stomp. And then there's this new pedal, or these new couple brands of pedals, one of which by this company called Hotone that makes a pedal called X Stomp, which is actually also a Bluetooth controlled pedal. And that's sort of the main product that was already on the market that sort of inspired this project here. I guess you could see, I don't have a mouse, so I can't drag around, but the two pedals on the left have so many knobs. They have this complex screen, and the processor in there is really, really intense. There's a lot going on, and from my personal experience, they're sort of hard to use, but I'll touch on that later. So one of the main problems of MultiFX, or one of the main problems that MultiFX pedals in general are trying to solve, is the idea that conventional pedal boards with analog pedals can be really large and unwieldy. Imagine trying to take your pedal board on the subway. That might be really hard. A MultiFX pedal offers a all-in-one solution. The second one is analog stomp boxes have limited sound possibilities, and this might ruffle some feathers. But with an analog circuit, you can only do so much. Even if you have 100 knobs on a pedal, that's not even really, that never happens. These analog pedals are indeed limited, as great as they sound. And like I touched on before, MultiFX pedals lack intuitive UIs. A lot of the time, it takes forever to get running with a sound that sounds good. And it has a steep learning curve. So the goal here is to provide a MultiFX unit that is easy to use, convenient, and also really sounds great. And so this is what I mean by the problem. Imagine taking this on the bus, or even in your car. You'd have to load it in. You'd have to have a big car to carry this, and they're heavy, and it's a struggle. And also it's a struggle for your wallet too, to buy all these pedals. So sort of the solution to come about, meeting these goals is, one, to design the Stompbox to feel analog. One of the big issues with these digital MultiFX pedals is that they feel digital. They don't feel like an actual pedal that you could use just normally like an analog pedal. And the way to sort of go about this complex parameter selection and MultiFX control is through an iOS app. So all the parameter functions are sort of abstracted onto the iOS app to control the parameters. And also the DSP parameters are not, I'll touch on this later. The DSP parameters are more higher level than lower level. You can only mess with certain parameters for each effect, instead of, for example, the axe effects, where you can go into every little detail. There's a market for that, but that's not what this pedal is trying to achieve. So there's a couple key design requirements that need to be met. The first is low latency. You need to have low latency guitar, or else it's impossible to play. Stereo, just to support more stereo effects such as reverbs and interesting delays. And then compatibility with existing pedal setups. The idea with this is that you would place it on your own pedal board and use it like an analog pedal. So it has to, output impedance, input impedance has to fit with that, as well as power requirements. And then also a small and lightweight form factor, because why even try this if it's not going to be portable? And also easy to use. So there's a couple key challenges that come through this, this trying to meet this goal. And one is audio pass-through. How do we get audio through the device? The main problem is really how to format these parameters. How do you get the parameters from your phone to influence the DSP on the pedal? And then the other problem that I really didn't anticipate was how to handle both the Bluetooth parameters and the parameters from the knobs through the ADC. That was a big struggle, and I'll touch on how I solved that later. And also real-time glitchless updates of the parameters. When sliding the parameters or using the knobs, how do we get it so that it doesn't affect the audio in any negative way? So just to touch on some of the embedded design, I can skip through this because it's pretty technical, but basically I'm using this chip called the Daisy Seed, which has an STM32 processor on it. Basically, it's sort of an all-in-one breakout board, similar to an Arduino, to just worry about audio. And it has a really nice audio codec on it that's already sort of set up. The peripheral is already set up for that. That's what it looks like. And then in terms of Bluetooth, I'm using something called the HM10, which that looks like that. So here's the iOS app. Basically, you just control the parameters. And it's Bluetooth low energy. So as soon as you boot up the app, it automatically connects to the nearest pedal. So you have sort of an effect select, and then you also have sliders. And then there's also, for certain effects, there's knobs, there's toggle switches as well. So you can toggle different parameters. So the solution for the parameter encoding is kind of interesting, but there's a problem to it. You know, how do we send over these values efficiently, and how do we store it in a small size so that the microprocessor, being an embedded system, doesn't have a hard time processing it? The first option was JSONs, but it so turns out that in order to deserialize JSONs, you have to use these massive libraries in C++ that take up so much storage on the microprocessor. So that's really just inefficient. And then also sending over the data, you know, you're sending over pieces of data that don't actually really matter in terms of the parameters. So the solution here is to make a custom bit structure, which is what I did. And basically, it's just 2 bytes that contain the index and the value. And certain indexes mean certain values, and are decoded as such. And so you get 0 to 255 range for each parameter. I can skip over this, but basically just the sort of the flow of how the parameters get into the DSP. Starting on the iOS side with the view controller, handing it to this Bluetooth handler that sends it out over Bluetooth using the core Bluetooth library. And then on the embedded side, basically just reading into a DMA buffer and into this parameter structure that I created that is going to handle all of the parameters. And so I'll touch on this a little bit. One of the big issues I encountered was because we're only using 1 byte of resolution for each parameter. When you move the slider, it really you get a lot of clicks and pops. Basically, just high frequencies is when you change the parameters. So one solution was to do linear ramping over time, but on an embedded system, that's not the most efficient way to do it. So just implementing a low-pass filter sort of solves that issue, or at least tries to reduce it. It's definitely a aspect that needs to be improved on in my code, but we're getting there. I'll skip the audio handler, but the DSP effects just include overdrive, chorus, auto off, phaser, compressor, and there's support.
Everyone else is moving.
Yeah. Did my computer? Wait, I see some movement. Yeah. Uh-oh.
Yeah. Oh, we lost her. Oh no.
Leah, you're back.
But it seems that she's
muted though.
Yeah, you're muted.
Oh, there we are. Yeah, I lost everyone, and then okay, good. I'm back. I don't know what that was.
Okay.
All right. So just wrapping in base class to handle it on my own end, and then calling in the audio callback. And then there's this one global state that determines, you know, which DSP object to call. the key point, and I learned this the hard way, is that parameters are to be updated outside of the audio callback. I was getting so many glitches when I was putting it inside the audio callback, and I moved it out to its separate routine, subroutine, and it was perfect. So another really fun aspect of this project was the designing the outboard audio analog components of the pedal. To just provide the ADC and the DAC out to the rest of the pedal board good signals, I just put some op amp buffers just to simply boost the signal and bias it at 2.5 volts on the input and 5 volts at the output. So here's sort of what the pedal looks like on the inside. It's a little messy, but what can we do?
That's what most pedals look like on the inside.
Yeah, exactly. Right. So here's the Daisy C. That's just the main microprocessor. The arrow is actually not pointing to the processor itself. It's pointing to the RAM chip, but that's besides the point. That's the HM10, just handles the Bluetooth, and you can see its little Bluetooth antenna. The power supply, and then the audio buffers are just underneath the pedal. Some struggles and some pitfalls are that the DSP effects are not modular and are currently hard-coded in the code. And then the parameters are locked to either reading from Bluetooth or reading from the ADC. And the way to solve this without going in the multi-threaded route was just implementing a switch on the actual pedal that determines whether it's reading from the switches or from the knobs. So the idea is that you put it on your pedal board and you can select the parameters of your phone, but if you want to use it like an analog pedal, you simply just turn the knobs and then it works perfectly. I already went over the parameter smoothing, and then also the circuitry is just messy. So the future of this and where I see this heading is getting into analog effect modeling and amp and cab simulations, really trying to make this as close as possible to a real analog pedal, just with these sort of modern Bluetooth connectivity elements of it. Also daisy-chained effects, so you can have multiple effects in the same chain. A prettier iOS app, because I'm not the best UI designer. And then just the design of a custom PCB, which I actually started on, but as I found out the hard way, they don't work. So that's a struggle. And then also on-the-go effect downloads. It would be really cool to have an online database of all these different DSP effects. You can just download onto whatever pedal you have. Imagine 10 people, all your friends have these pedals, and you find a new effect. You just download it with your phone or upload it to the pedal with your phone. That would be super, super cool. So here's a little demo of the pedal. Let me know if you, oh no. Let me know if you can hear it. I hope so.
Nothing.
Uh-oh, okay. Oh, it's because I did not share sound, so let's do that. Yeah, I did not click share sound. Yeah.
Mistake.
Okay. This is the actual demo of the Bluetooth. Okay. That's the demo. I'll leave it up for questions here with this pretty picture of the cicada. So.
Yeah, I have a question. For the effects, did you code all those as well?
No, so the effects were actually, with the exception of the overdrive, they were implemented using this DSP library called DaisySP, which comes with the Daisy seed. Most of the lower level for the modulation effects, most of the lower level like circular buffers and all of that already implemented, so I didn't need to worry about it.
Oh, nice.
Hey, Leah.
Hi.
Just curious. So you've got 4 hardware knobs and generally 4 sliders on the tablet screen. You know, the iOS screen. Is that right?
Yes.
And they always match up 1-to-1.
They do. So I'm trying to pull up the app on my phone here. The first knob, the top knob matches up to this knob. So the idea is when you load in an effect on the app, you can sort of see like, oh, the top knob is this knob.
Yeah, perfect. No, I'm just thinking about being on stage and scrambling for parameters and kind of wondering what was what. But right. Yeah, being consistent with that would make all the difference. I think it's awesome, really.
Thank you. I think in the future, definitely the UI on the app is going to map 1-to-1. My UI skills for iOS are just not there. So really just getting something that works before making it look pretty. But thank you.
Doing fine.
For the knobs, when you adjust an analog knob, will the digital slider snap to wherever you put the knob?
No. It's only sort of a single way communication from the app to the hardware. There's no updates on the iOS side when you move a knob.
Gotcha. I don't remember if I can't remember the list of future improvements that you discussed, but was like having presets and set lists and things like that in there?
Presets are definitely something I considered. More, I guess, user customizability for these I guess there's already the presets, but user customizability of them is definitely something that I would want to add in the future. It's just a large task. So it's something that I looked into.
Those are analog knobs when they're going to an ADC, you said?
Yes, they're not encoders. They're just like 1K linear pots that I have going to ADC. Yeah, exactly. The point was to make it feel not like a MultiFX pedal, so that you look at it and you're like, oh, that's a regular analog pedal.
All right, great job.